Hey, everybody, welcome back to the Transformation Leaders Podcast. It is Wednesday, 12 o'clock noon Eastern Standard Time. I'm with my co-host here, Sean Ennis, and he has got a fantastic show lined up for you with a little bit of demo. We're going to talk a lot about RAG and how everybody should be thinking about it, using it. We got a special bonus for you at the end, so make sure you stay tuned. And I'm going to pull up the slide deck today for Sean. And, before we begin, I just want to say that if you're doing anything with AI and you have not heard of RAG, well, welcome to the modern day, because it's been all of the rage, not RAG, for the last 2 years. And it's even moved on and continues to move on. So whatever we show you, whatever we tell you, just know that in 6 hours, it's all obsolete. So, with that being said, Sean, you want to kind of walk us through what you've got here?
Yeah, and again, RAG is one of those things that people eventually get to. In your AI journey, you have probably created a prompt before, and then maybe you've used a public large language model system like Claude or ChatGPT, Gemini. And you've probably added a file like I did this last week doing some electrical work. I didn't know what it was, so I took a picture of it, sent it over to Gemini and says, hey, tell me about this, and found out exactly how many volts I was messing with. So, that's a lot of people are getting there. Now, when you get one step beyond it, you want to add your own data to the large language model beyond just a file. I have this with clients all the time. They're like, Sean, I can only add 20, 30 files to a prompt. And I'm like, whoa, you can add 30 files to a prompt? That's amazing. Things that you've never even thought of trying to do. But once you start getting more and more of your files that you want to do queries with, you start getting into RAG. And this is just adding a layer of embeddings, or as David, when he educated to me on what RAG was, he said this is the sidecar. So you have your large language model as the motorcycle, and then you have a vector database that sits on the side that will have all your information pre-processed, so that when you make a query, all of that is combined together. And one of the things that a lot of people tell me is RAG is just too complex, or it's too costly. I don't have the money to do that, Sean. The hardware is too expensive. Well, that's the impetus for this conversation today, because really RAG is something that has gone beyond the experienced, and now the inexperienced can do it as well. So starting with that, what is RAG? So as I stated, the large language model limits how much of your data can be involved there. The other issue that people have is large language model was created using the data from the internet. So it's like shouting at the internet. I don't know if you've ever done that. I think everybody has done that at some point, but you're not going to win. There are more people putting their data in there. So a lot of people, they just want to see their data. And that's where I'm doing today. I'm not adding a large language model to it. I'm just creating a blank slate, my own little small language model that we've talked about before. And you could be ultra specific in the knowledge that you have. In fact, the example I use today is I went to a large language model and said, hey, write me a 500-page novelle about a fictitious person. And it created it. And then I ragged it, put it into the system, and I could start asking questions. You could take your proprietary knowledge, things that frankly, you don't want the world to know about, and make it available. So these tools were only available to the Googles 20 years ago. And now you can do it, as I show, within 30 minutes, you could have your own custom knowledge base. And a lot of people are doing RAGs just to figure out how to do it, from an engineering perspective and the trials and tribulations. That's part of the reasons that I'm doing it. And then some people, they come up with every reason you want to be able to play with technology. And you could put me on the list for all 5 of these today. Any questions, David?
Nope. Sounds good to me. The only thing that I might add a little bit to that is that, as things move forward progressively, and as everybody knows, and especially you, Sean, I live in the low code, no code world. And this is becoming so ubiquitous that it's almost like second nature. A lot of these user interfaces or things or applications or tools that you'll use where RAG may or may not be applicable, depending on your use case. It's as simple as just browsing and adding files, and all of the magic happens in the back end. Also to that end is that you have the ability to add URLs, and it will go out and crawl like first level links. Some systems are a little bit more specific, or allow you to do some configuration to do level 2, level 3. So if you think of a menu system or nav bar on a website, it'll go to those second or third level pages, usually no more than 3 layers. But in any event, what Sean's talking about, what Sean's showing, is the more traditional, regular developer geeky kind of way of dealing with this, because it's a little bit codey. But just know that if you're on the low code side, like I am, and I live a lot in, this stuff is so easy to do now that it's like second nature. And you may not even heard it called RAG. It just says knowledge base or knowledge. And so just to help sort out any confusion, all of these terms mean all the same thing: RAG, retrieval augmented generation. And as we move into the new era, the retrieval part will become less and less known, and you'll just get augmented generation, which is now 2.0 and coming, but that's a whole nother show. We'll get into that later.
And like I said, everybody is on their own journey. Maybe you have just started doing prompts, right? Maybe you're doing fancy things like taking pictures of electronics and finding what kind of voltage it is. But everybody is going to experience this in some way or another. And there are 50 steps behind this. So let's jump in and understand how the RAG knowledge lifecycle works. So you have a teacher. This would be more of a human. And a human will create documents, and they would provide it to the system, aka ragging your data, so that it can then ask a question. And then you will create a quiz and test it to make sure that whatever you told it, it actually is providing you the correct answers. You modify your data, and then you retrain, and then you test, and you modify your data and train and retest over and over and over again. This cycle, it's called the knowledge life cycle. And there's a lot of people out there who, instead of using the automated testing, they're using organic testing. So you'll have human beings in the testing that would say thumbs up or thumbs down. But this is the process that things go with, and you're constantly trying to prove this model. Now, I'll show you what I did first scale and the results I got without doing any kind of modification of the data. And you could see why we call it a life cycle. So a little spoilers there. But at the end of the day, this is how it works, is you have a teacher who creates documents, hands it to the system, the AI learns. Then you test what it learned, and then you modify the teaching and reteach it, and over and over and over and over again until you get a acceptable quality of knowledge. And I'm showing you how this is being done for basically a small language model, but this is basically how they do it for the big ones, except it's much larger, much more convoluted, using algorithms to automate a lot of this. So what do you need to begin? Well, you need a piece of hardware. Now, can you use your laptop? Yes, you can. But when you're ragging a document and your whole laptop freezes up because it's using all that hardware to go as fast as it can, you may want to have a separate piece of hardware. And this is what I did. So Friendly ELEC, think of them as the Chinese Raspberry Pi. They offer a really compelling device that's an 8 CPU, 16 gigs of memory box. It is $100, and this is what I'm using. Why? Because I have lots of things that I want to do, and while it's compiling all this information, I don't want it to mess up my laptop when doing it. And I want something that I can throw away and bring it back up to do many different things. So this is why I bought it. And then I have a subscription to Claude, and a pro license costs $200 for a year right now. And this is what you need to do, but you also need good data. That's the thing that everybody forgets with this. Hardware and software, but you need the data. If you don't have good data, you're going to have more life cycle iterations and more testing.
Garbage in, garbage out.
Think of yourself as a teacher, right? You're going to teach a student. What do you need? Well, you need a book, right? A textbook that you're going to hand them so that they can learn from it. And then you need quizzes for that textbook so that you know that they comprehend the material. And then you're going to quiz them. And if they fail, you're going to take whatever that they failed on, you're going to focus on it, you're going to teach more specifically to those areas. And you're going to rinse and repeat until they pass the class, right? This is effectively what you're doing with RAG. Any points you want to make, David?
No, the only other thing is that the hardware is going to be mileage varied. So depending on whatever it is that you're doing, and also depending on the machine's load, Sean's showing almost a Raspberry Pi-ish type thing here. And so, yes, these are performant. Some of them can be quite actually impressive, especially if you have, I think it's $200. NVIDIA makes this insanely awesome unified memory thing. Also, the Mac Minis, obviously a little bit more, but if you can get your hands on I think they're at Amazon right now. I bought one recently. I think I paid like $500 for it, which is way more expensive than what you're showing here. But performance wise, the point is you can get almost server level quality production for a couple of $100 and up to maybe 500 or 600 on the Apple Silicon. So just know that, even though that the hardware may present some issues for you there. And the other thing too is that forgetting all of the hardware, you can very easily with Docker running on your machine, assuming you have at least a decent enough machine, you can run all of this containerized, and everything that Sean's going to show, the code examples, you don't even need to be buying the hardware. You can simply run all of this on Docker. Obviously, that comes with a lot of extra technical skills that you'll need to have, but there's things out there on AWS and Linode. You can get free hours from Amazon. You get free hours from AWS if you don't have a cloud account. And so you can start kicking around all of this stuff. So the learning is, long story short, or point here is that you can get free stuff that's super powerful, or if you want, you can invest $100 and just keep it off to the side, because there's a bunch of other cool things you can do with that device that Sean has.
Well, I want to repeat that. So you could get a 16 gig, which is what this has. You can get I think it is 8 CPU and 320 gig drive for, I think it's $400 a year, right? Hosted in the cloud. So for 4 times this price, you can have a cloud resource, right? Really cool. I bought a mini box on Amazon that's 64 gigs of RAM, a 2 terabyte drive, and 20 core box.
Ouch.
It was $450.
Wow, you got a deal. You should have shared that with me.
You could certainly go through and buy a 16 gig M4 Mac Mini. I have one. I use it for my workstation. Incredibly powerful from a CPU perspective, but to upgrade the memory, it's incredibly expensive. I priced a box, call out to Serve the Home. If you look at YouTube, Serve the Home, they talk about this all the time, where they have a home box that it is, I believe it was, I think it was 28 core, 128 gigs of RAM, and 6 terabytes of SSD in RAID for $1,300. And it's just, a little box. So the hardware, Amazon sells them incredibly cheap. You can buy online. There's so many different things. I bought this one because it's very small and it's very portable and it's extremely new. In fact, all the distros for Linux currently do not run on this. You have to use a specific distro that the manufacturer provides until Linux can support it. So again, your mileage may vary on hardware. I could tell you the bigger the hardware, the faster it goes. Just to rag a 500-page novel was 40 minutes on this box. But you do that once, and then the queries are about 30 seconds. So, obviously, if I were to do that on my $500 box with 64 gigs of RAM, it is probably at least half. It takes half as long, maybe even 90% quicker. So, and then, as you said, there's plenty of different people out there who will give you free trials to play around with stuff. But this is mine, and I can beat it up till it breaks, and that's why I bought it. So, the first part, if you haven't seen How I Vibe program from, what was that, 3-4 weeks ago, check it out. And you can see what I did here is that's the prompt I ran. So write me a bash script on Ubuntu. So I tell it what I'm running. This is the Linux distro that I'm using. I tell it specifically what to install. Quadrant is the sidecar, that Vertex database. Fast API is a library that builds different APIs because I believe in API first development. Even if it's for my own little playground, I use APIs because you never know when you want to create a user interface, like a web interface or a mobile interface. You want to integrate with anything. Having a REST interface makes the most amount of sense. And then I tell it to use Ollama. That's the large language platform that I'm using. And then the models, I'm using Qwen 2.5 because asking AI, it told me those were the fastest ones for a very small RAG. And obviously, the better the system you use, the more resources and the better the results. So you have to trade off how many life cycles you want to do because your model isn't smart enough versus how much resources you want to spend. Because I built the hardware as being the constraining force, it means I'm going to have to do more iterations. But if I, work for Microsoft or X or Tesla, and they have a huge honking hardware that I can plug into, maybe I can do less iterations because I have better hardware. And algorithms change everything too. So this is really what is the forcing factor right now for new models being so awesome is that people are developing new algorithms to RAG data, basically, or learn from data, compile data. And then number two, the testing. So remember, there's training, and the second part is testing. And those were the algorithms that people are making these better and better and better so that you can train faster, you can train better, you can test faster, you can test better. And then I told it to use an API to be able to support querying and loading data, or as you can see, chunked into the RAG. And then I said, hey, give me curl examples so that I can just copy and paste, because I'm lazy. I don't want to just figure out how to do these commands. Remember, this API is being created by the AI on the fly. So I don't want to figure this out. I want it to tell me specifically, this is what you do. And then I tell it specifically, write me a bash script, because I don't even want to use the curl statement. I really like AI and by programming because it reduces the level of effort I have. So I was able to spin this up and start it working in 5 minutes. So after I installed the operating system to after I have the complete system up and running, ready for me to use, 5 minutes. And that's what I mean. I barely tried here. I spent more time trying to figure out, okay, now that I have the RAG system, what data am I going to use? And how am I going to test it? And so that's the next part. So what I did was, I'm like, okay, I can't use proprietary data because this is a public show. It limits what I can do. And I don't want to go onto somebody's website and highlight them. So what I did is I just decided to go into AI and say, write me a 500-page novel about some random guy, right? So you could see I asked questions like, who is John Galt? Some of you might know that reference. But it says, hey, nothing found. I have an empty knowledge, right? I asked, what is D&D? And it says, I don't know. So I asked it two contemporary pieces of information that you can ask. And if you're interested in what both those things are, you can ask the large language model and it should give you an answer. So I went and I tested. The first thing I said was, tell me what you know. Do you know anything? Sometimes I ask, my typical question is, why is the sky blue? I ask the question, what is the capital of France? And it'll tell me this information, or in this case, because there's nothing in the knowledge. And I built this knowledge engine to not use the large language model knowledge. I want only mine. It's a small language model for me. And so what I did is I uploaded that 500-page novel in 219 chunks. It took about 30 minutes. It's not fun to wait 30 minutes for this. But like I said, it would have been 5 to 10 minutes on a $500 machine. So, it's your money. It's not mine. So it's up to you what kind of patience you have versus what kind of checkbook you have. I know what I have of both. So this is kind of how you load the engine. So, first of all, you need the hardware. You need to install the RAG system and the API and the vector gateway, the vector database. And then you need the data. You need to load the data. So we're almost there, David. Any questions before I show you the grand reveal?
Nope, but I can see folks watching this thinking one thing, and that's because they always think it. And unfortunately, it is what it is. This is a lab. I want to reinforce this. This is a lab, okay? So the The answer to the question that I know is blaring in somebody's mind because they're coming from a technical API background and blah, blah, blah. And they're like, where's the security? Where's the API key?
Nope.
The bottom line is, yes, you can add one. It's a simple parameter. When you launch it up in a Docker container, and then in the header, you can include your API key. So breathe. It's all gay. This is this little pie looking thing. It's in the house. It's not doing anything. It's just meant for simplicity. It's a learning lab. It's for an exercise. It's not exposed to the outside world. So if you're thinking that, I just wanted to head that off at the path because I'm sure there are a couple of people out there. Why isn't this thing secured? And you can secure it if you do decide to open this up and play with a lab in the real world and out in the environment or whatever it may be. But yes, just know that you can secure it down. But that was it.
There's security, there's scalability. Like I tried to rag 2 docs at the same time and it ground it to a halt. This is a playground so that you can learn how to do these things, and that it is incredibly easy to start your journey. This is not precision craftsmanship. Like, if you want precision craftsmanship, hit me and David up. We'll bring you into teams of people who that's what they do for a living, right? This is to make sure you understand what is possible, and more importantly, what is the process. Because if you're going to do an AI journey with knowledge, I hope you understand so far the technology is the easiest part. The data took longer to get, and certainly, as you'll see, refining it than anything else in the picture. So the technology is the easiest part, is my point.
Yep.
Now, querying, as you can see, I started asking it questions like, hey, I asked it the question about what is D&D, and it's like, I'm not quite sure. Which was an interesting answer. And then I asked it, I created a novel on the fictitious character of Hans Franz Wayback. And why? Because if you can see the top right, I asked 2 different large language models, who is this person? And they're like, nobody significant was ever named this. So it's safe. This is why I created the data. I needed to create something that, number 1, was completely unique and proprietary to me. Number 2, data that was not conflicting with the large language model that I'm in. So here's the thing that I always get into trouble with talking to people. You don't need to do a knowledge base if the knowledge you're trying to add to the large language model is already in the large language model. I don't know why this is a confusing item for some people, but it is something that you have to remember. Obviously, it's logical and makes sense, but people are like, hey, Sean, I want to get this in the large language model. Okay, did you try querying the large language model before you added it? And they query it, and they're like, oh, it's in there, and it's accurate. Oh, okay, I solved your problem and saved you money. Thanks.
Yep.
So this is why when you're looking for an engineering solution, many people, I know I am there, they start with what I'm going to show you last, which is the testing. So the test that I showed here, I wanted to make sure that it ragged the system. It now sees something. It knows what I logged. So I know that from a load perspective and in engineering, the system is set up and it is basically functional. But is it accurate? And that's the last piece that I wanted to show here, which is testing it. So what I do is I said, hey, write me a Python script that will take ground truth answers. So you can see here's some what I call ground truth answers. You want to create some easy questions, some hard questions, some complex questions, right? Easy questions are yes or no answer. Like, for example, what ominous sign marked Hans' birth in 1955? right? Lightning struck 3 times during a thunderstorm. That's the answer. So easy questions should be an easy answer, and very short and to the point. When was he born? 1955. That is a simple, easy question. Now, a hard question would be like, hey, tell me the 3 people this person married. So you got to remember all 3, and you need to remember, that there were 3. That's a harder question. And then, you could see the complex is like, okay, understanding the technology of that day. Explain to me why this happened in this, like this. This is a very complex answer that needs to be generated. And this is how you test a knowledge system, is you ask it very easy questions, very hard questions, very complex questions. And you do as many as you can. The more questions you have, the more likely you'll have quality answers. Now, I say this all the time and people lose it. If you're expecting greater than 80% accuracy, you need to think again, because the knowledge systems, you may be able to get 85, maybe 90%.
That's good.
But large language models are not built for 5 nines. If you're looking for 5 nines, you better hire a lot of Einsteins.
Yeah.
And as I understand it, he wasn't that good with algebra. So, again, you've got to be on planet Earth. This is mathematics, not magic.
Yeah, let me just add one thing to that too. Is so another approach when you're testing these, just because, okay, so I guess a couple of things. Let's separate some concerns. So you've got the vectorization, you got everything in the vector database, and now you're also testing. So Sean's giving one paradigm and one perspective. The other thing too is that you can think about is using these larger, more complicated, not on that Pi type device, but if you had a different hardware where you could run a more complicated model. What I'm trying to get to is the thinking models will help you deal with understanding what's going on in the hood, because you can watch the thought process and how it's trying to assimilate or compile or bring this information together. If you have the smaller one, you can use chain of thought, prompt techniques to kind of help it explain step by step what it's doing, and you might be able to troubleshoot it that way. But just know that your troubleshooting techniques for the harder type of questions and these types of analysis type questions is going to be a little bit more challenging, because if you think that you just use the one model and only the one model, then you've cut your nose off to spite your face. You're missing the value and everything that's out there. So lean on prompt engineering when possible, when applicable, based on resources. Use your either a chain of thought for cheaper versioning, or just cut straight to something like DeepSeek or other, what is it, Llama 4 now that does chain of thought or thinking on that. Anyway, I can't think off the top of my head which one has all of that. But the keys here is making sure that you think about all of the different techniques, prompting techniques, and other type of models to test your vectors, and making sure that they're there. And the other thing that I personally have found is when you're setting things up for chunking and overlapping, I usually follow a rule of 10% overlap as a rule of thumb. So if I've got, 100 of whatever, I use my overlap of 10. And I just want you to think of a chunk here, and then you just kind of blend it by 10%. If you do that, your vectors usually tend to come out a lot better, and you get better results. So just a couple of quick tips and things on troubleshooting and when you're also doing your chunking and overlapping.
Yeah, well, just like my friend Hans, you're stealing my thunder here.
I'm so sorry.
Because that's really why I wanted to get to next, which is understanding this is as far as you get by doing one cycle. So knowledge management is a life cycle, not a task. Yes, you could set up the system and be done, But as David just said, okay, then you got to do testing. You need a test harness. You need security. You need scale. You need redundancy. You need all these other things that you'll need. But let's say you did all that up front. This is what you can expect, right? So I ask it, what is the ominous sign, like from the ground truth? And it said, like, oh, I don't know. The most simplest of answers, right? I don't know. And it says, okay, now what was the first technology achievement? And it said, building a single computer with vacuum tubes. And again, not accurate. So, and it says, who did he marry? Well, it's like, yeah, I know who he married, but I don't know exactly about the wedding ceremony. So you could see it worked, but the quality of data with one set of data, when the overlap, so it, just as David was saying, how this works is it will take and break up that 500-page document into 2-page documents, 219 chunks. And then there's this overlap. And so that is the key when it comes to RAG, is understanding your chunk size and understanding your overlap. And right now, this is the voodoo. This is the art of RAG, is understanding the data well enough to do that. And then maybe we'll go in the future, because I've seen plenty of people with techniques that basically you give the document to a large language model and you say, what should the chunk settings be? And then you could certainly do that as part of your knowledge management, where you would have a precursor before you chunk anything, you go in. But this just gives you an example that while setting up RAG is the easy part, getting your knowledge where it needs to be is really the difficulty. So I'd like to finish up by saying that RAG is a GenAI 101 type skill set. You must learn it. You must understand it. Do you need to do it? No. But you do need to understand it. Because if you're using GenAI at all and something goes wrong, understanding what the cause is would allow you to make the right decisions on what to do. I don't know how many people said, oh, this model's awful. Okay, well, why is the model awful? If you go through and build a model yourself and you experience the changes, you teach an AI assistant how to do its job, you will have a lot of clarity to understand how these things work and what is possible and what is myth and what is legend. So knowledge is a use case that almost every GenAI use case that I'm running into is asking for. Because many people have proprietary things that they want to do these things on. But there are plenty of use cases that don't use it. So having this skill allows you to understand where it's applicable and where it's not. This is very easy using GenAI, as I showed. I did this whole thing in 30 minutes, over the weekend. It doesn't take long. And the hard part is getting the high degree of accuracy. The data and how you chunk the data and how you overlap the data is the secret to that success. Yep. And you need to be prepared to test as often as you tweak the data. So 10, 15, 20 iterations is typically normal. And then you have regression issues. If you introduce data that conflicts with previous data, you're going to get hallucinations. And as you saw, that's what I got. Those were hallucinations. I told it the right things. I just told it confusing things. So I need to go through and take that, read through the data, and find out what data is driving these confusion points. Check to see if the chunking was wrong or the overlap was wrong, because it could overlap right on the word wedding. And so it says wed and it says ding. And those are two different things. And that key word, there was no context.
Yeah, the one thing to keep in mind is Sean said it took him 30 minutes to put this together, but 30 hours spent testing it.
I mean, if you want it to work, 90% of the effort is in testing and data. 90%.
And I think that's the thing that most companies don't have a good appreciation for. So they think in terms of maybe staff reduction and doing whatever, but the reality is coming that it's not a reduction in staff, it's a shuffling of responsibilities and shuffling of, you may have people that might lose their jobs because they don't have the skills in one area. But while you might lose something, if you had a process where you had 100 people spread throughout the process, they were evenly distributed. Well, now everything on this side is like streamlined, but now you've added such a bulk to this other side. You still need the 100 people. You just need them on the back side of the process, not on the front side. So right now we've completely changed the way that everything is being done. So that's the disruption here, is getting your business process in a way that it's understood, and understanding the cart doesn't need to go before the horse, and making sure you have documentation about your business processes. Because as departments try to explain this to senior leadership's not in the trench. They don't know what's going on in the day in the life, so to speak. Some do, but most don't, especially in larger Fortune 100, 500 companies. You just can't do it. The scale just doesn't work there. So document all of this stuff. And as you start moving through all of this, you're going to start seeing that you're going to need people on the backside of everything that Sean just showed you here today.
Yeah. Well, I mean, I want to call out, Azure, Google, AWS. They have all these tools to have you stand up your knowledge base in the cloud very easily. Now, David, of those three platforms, which platform offers you a complete testing tool and data management tool so that you can automate the other parts, the 90%?
I've used all three of them, but I think Google, in my opinion, has some of the best suite. I have not played around with Amazon too much lately, so I'm at a little bit of a disadvantage.
I can tell you, out of the three that I've played with, none of them have a testing harness for knowledge. None. You have to build it yourself, right? Any kind of data review, any kind of chunking strategy and dynamic management of chunking strategy. All of these are huge gaps. And so what happens is people will deploy a knowledge system and they say, look, it's garbage. This stuff doesn't work, right? So I want to be clear. I keep running into the same type of people. Number one, who say, pretty soon we're all going to be working for the machine, Sean. There's just going to be Arnold Schwarzeneggers on every block killing people. No, that's not happening. Number two is, hey, this stuff just doesn't work. Well, trust me, trillions of dollars are being spent. It works. You just need to know how to do it. And that's why we have this today, is to tell people, yes, it's easy to learn. And once you have done this yourself, you kind of get it. Like, wow, we're spending all our time talking about setting up when the hardest part is managing it after the setup.
Yeah. And when I run into these challenges that you talked about with the missing pieces in the test, this is kind of my go-to, or at least the first tool that I use to go to, is using LangFuse to try to get some forensic data about what's going on. That's usually my first stop. So rather than build something, first try there, go there, see what value you can find, if any, from that. It may save you a tremendous amount of time because it does capture some really, really good telemetry and is able to capture a lot of stuff in the middle that otherwise you would simply just have to write traps for.
Yeah. Oh, one last thing I did want to bring up, David, is the final thing. Is now you may have heard a new job role called AI supervisor, right? So you may have wondered, well, what do those people do? What those people do is they teach AI. So as part of that life cycle, if I go back to, what was it, slide 3, they sit over here on the left training, and they sit on the bottom here testing. And so they ask it a question. If it says it got it wrong, it tells them, no, this is right. And then they're actively training AI so that AI gets more data and more good data from a human. And this is how people are doing it today, because instead of getting experts and documenting data, it's easier to fix it as you go with AI supervisors than to do what I'm recommending, which is get your data set right first. So there's an organic approach,
Yep.
and then there's a holistic approach. And what I'm hearing is many more people are more comfortable fixing this as we go than starting out correctly.
And
that's where AI supervisor comes from.
Yeah. And if anybody's interested in digging their hands deeper into what's going on, you can reach out to Sean or myself out there on LinkedIn. But more importantly, I promised you a free giveaway at the end here. I'm going to bring this up for you to kind of show you what this is. I'm not going to spend a lot of time with it. It's a 7-page document, but it is a beginner's guide and talks a little bit more about Quadrant and how you can get into the different settings and kind of break it down into more of a plain English, as if more at a high school level to try to do. It has some code examples and things of that nature. Anyway, I've made a post out on LinkedIn. So if you follow and get to Sean and I on LinkedIn, you should be able to find your way to this document. Otherwise, if you can't, you can simply just scan this QR code now, and it will get you straight into that document, and you'll be able to download it and then disseminate it wherever you guys want to be. But anything else to add?
No, really appreciate the time of everybody today. And, if you have any questions, we're here. So reach out. Love to talk to you about it.
Yep. Sounds great. And remember, guys, we are here every Wednesday at 12 noon Eastern Standard Time. And that's it for this show. So we'll see you next time. Have a great day, everybody. Bye-bye.